And now guys, after we talked about the equation of the straight line, we recognized the slope, the y-intercept, how to draw a straight line using its equation by taking 2 points. Now we are going to talk about the relative position between lines. Let's think a little bit. How can lines be? If you have two lines, how can you imagine them? Let's see. I can have parallel lines, or I can have intersecting lines. Intersecting lines may be any two intersecting lines, or they may be special intersecting lines which are perpendicular. So lines can be parallel. If they are not parallel, then they are intersecting. And a special case of intersecting lines is lines that are parallel. What relative position can a line? Can two lines have also or more than two lines? They can be confounded. What do you mean by confounded? When two lines have the same equation, here is the first line and here is the second line, they are said to be confounded, mean they have the same equation and they are coincident with each other. So, to sum up, lines may be parallel, may be intersecting, and a special case of intersecting, they may be perpendicular, and lines also may be confounded. Now let's specify each relative position alone. The first one, parallel lines. So we are going to talk in this slide about parallel lines. In general, let T have the equation y equals ax plus b, and D prime having y equals a prime x plus b prime. Note that y and x are the same. Here a and b are real numbers that are different from these a prime and b prime. So a, b, a prime, b prime are any real numbers. These straight lines are said to be parallel if a equals a prime and b doesn't equal to b prime. What does that mean? That means that two lines are said to be parallel if they have equal slopes. So if a equals a prime means the lines have equal slopes and b is not equal to b prime. This real number here should not be equal to this real number here. And here is an example to study the relative position of the lines D, which is of equation y equals 3x plus 5, and D prime, which is of equation y equals 3x minus 2. First of all, we notice the slopes. The slope here is the coefficient of x, which is 3. So the slope here is 3. Similarly, the slope here is 3. So I maintain that the slopes are equal. I still have to maintain that the y-intercepts are not equal, or else they will be confounded. So this is 5 and this is minus 2 that are not equal. Then I say that these two lines are parallel. And here is the figure showing these two straight lines. The pink one is line D and the green one is line D prime. And as you see, they are definitely parallel. Now, how did I construct these lines? As I told you previously, to construct each line, I just take 2 points or 2 values for x to give me 2 values for y. For example, here we took 0 and we got 5. We took, for example, let's say minus 1 and we got 2. And for D prime, we took 0, we got minus 2, and so on. When we join, we got 2 and 4. When we join the points, we got the straight lines and they appear to be parallel. And that emphasizes our rule that says that lines are parallel if they have equal slopes and different y-intercept. Now the second case of relative position between lines is the case of perpendicular straight lines. So one or two straight lines perpendicular if the product of the slopes is equal to -1, then these two lines are perpendicular. So again, in general, the line D is usually represented by D. This is line D, two dots, y equals ax plus b, and D prime is represented by D prime between parentheses y equals a prime x plus b prime. So a and a prime represent the slopes of the lines respectively, D and D prime. So if a times a prime is equal to -1, then these lines are perpendicular. Let's see the example here. Given the lines D of equation y equals -2x minus 5 and D prime of equation y equals 0.5x plus 2. What is the slope of line D? It is -2. What is the slope of line D prime? It is 0.5. If their product is -1, then I say that these two lines are perpendicular. So -2 times 0.5 is definitely -1. Then I say that these lines are perpendicular. Now, I'm going to give you like a training exercise to turn your engines on, and here we go with the example. I want you to consider the lines D of equation y equals x plus 7 and D prime of equation y equals m minus 2x plus 3. My question is, find the real number m if D is perpendicular to D prime. So how can we find m if it is given that D and D prime are perpendicular? All what we have to do is to apply the rule that says a times a prime equals -1. So let's continue. Let's use the black color for the solution. So the solution, we write first of all the rule a times a prime equals -1 since they are given perpendicular. That means that the slope of line D, which is represented by a, that is the coefficient of x, which is here 1, times the slope of the other line D prime, it is represented by m minus 2, and their product is equal to -1. Now I multiply 1 times m minus 2, it is as it is, m minus 2 equals -1. So finally, taking -2 to the other side, we will get that m equals 2 minus 1, which is 1. Okay, so we can use this property also for solving such questions when the lines are given perpendicular and you have to find a certain missing